Hi there. In this next section, we're going to talk about limits at infinity. So what do we mean when we say that? We're basically saying, and if we take a look at this graph, you just want to kind of make a quick sketch in your notebook, that the limit as x approaches infinity of f of x is equal to what? Okay, so what do we mean by as x approaches infinity? Well, we're going to go out, x meaning the x-axis, so we're going to go out on the x-axis towards infinity, which is someplace obviously way over here. But our question is, what is the intended height? So the limit, again, is just the intended height. What is the intended height of that function doing? It doesn't actually have to reach a height. It's just what are its intentions. So if I kind of trace over this here, see if I can highlight over this. As I go out towards infinity, these x values, what are they approaching? What is their intended height? Well, it looks like they're getting closer and closer to 2. Now, they're not touching it because there's an asymptote there, but that doesn't matter because, again, a limit is the function's intended height. So I would say as x approaches infinity, the intended height is equaling 2. Likewise, if I do the limit as x approaches negative infinity of f of x, what is that intended height? So again, negative infinity would be way out here someplace. And if I were to walk on this line and head towards, go towards negative infinity on the x-axis, what is the intended height of the function? Well, again, in this case, I would say it's approaching a height of 2. Okay, so we want to walk out towards infinity and look at the intentions of the function. All right, question 2. The limit as x approaches infinity of f of x equals 3. Now, there's an infinite number of things you could draw for this, and our goal is just to come up with several different ones. So we're just going to make a quick x and y axis sketch here. And we'll just call this graph 1. And we want to say, as we go out to infinity, so as my x values get bigger, I'm only reaching an intended height of 3. So just pick your pen up and try to draw something. As I go out, I'm going to draw something very basic. As I go out on the x-axis forever, I'm only ever going to reach a height of 3, which means it's got to tailor off there, which creates this horizontal asymptote at y equals 3. Okay, now we could be really less, not super creative and draw something very similar. As x approaches infinity, so as I go out forever towards the x-axis getting bigger, I could only reach a height of 3. When if I did something like this, as I come down, as I'm going out on the x-axis forever and ever and ever, I'm only ever going to reach a height of 3. Again, I'm making a horizontal asymptote. And that's kind of the key. Maybe put that in your notebook there. Infinite limits. So as x approaches infinity, you should be creating a horizontal asymptote. Now, let's try to get a little more creative. I'll try to draw something else here. We'll do 2 more. All right, as I go out on the x-axis, I want to reach an intended height of 3. What could this look like? What if I did something like this? And then I could tailor off at 3. As long as I'm creating an asymptote here, I'm only ever reaching an intended height of 3 as x approaches infinity. Now, if you recall from a video we did earlier, horizontal asymptotes, you are allowed to crash them because it really doesn't matter what's happening in the middle. It's what happens at the very end when x is towards infinity. So as long as you're going out towards infinity and right at that infinite part there that you're looking at, as long as that approaches a height of 3, you're in great shape. So our 4th graph, draw anything you want, just as long as your function is approaching a height of 3 here. So I'm going to put an asymptote in at y equals 3. And you can draw any function you want as long as it's heading at the very end. It's got to tail off at y equals 3. So it either has to end up here or end here. But again, draw anything you want. The only thing I do want to say is make sure it's a function. And again, by function, it's got to pass the vertical line test. So just to be clear, that's a big no. That is not a function. It does not pass the vertical line test. But just something that passes the vertical line test and tails off at 3. Okay, Now, this is always going to be an AP question. It will be on every single quiz test every week till the end of the year. We do have to know our limits as x approaches infinity. So that's basically the question for the rest of these. What is the limit? And you'll kind of see it as we go, as x approaches infinity. All right, so I want you to think about this, of f of x here. If you're going out towards infinity, you're getting very, 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 very big. Okay, so if I said infinity plus 10, does 10 actually have any effect on that number or that value? No, because infinity is so large. It's not a number you can count to. It is just so large. This extra 10 that you have here means nothing. If I said infinity plus, 100 squared, even though 100 squared or 100 cubed feels big to you, it has no effect on the number infinity. So when you see the limit as x approaches infinity, you really only need to be concerned about the largest power. Okay, so I want you to put a little star in your notebook. This is key. Maybe grab that highlighter at this time. We want to compare the largest power. Now, if it's a fraction, I'm going to put plural because you're going to compare both the largest powers on the top and bottom, and you can add that into your notebook. If it's just a single polynomial, you're just looking at the largest power. But we're comparing the largest powers. So if I go back and I look at this function here, okay, clearly it's a rational function, so I have a fraction, so I need to compare both the top and the bottom. So what I'm trying to say is, when I take infinity and raise it to the 5th power and multiply by 4, these numbers are so insignificant, they don't really affect it. So I'm going to rewrite this function is really the limit as x approaches infinity of 4x to the 5th divided by, and again, this 89, insignificant, and this 200x squared means nothing compared to infinity to the 5th times 6. Okay, so a lot of times you'll hear us refer to this as a power fight. So maybe another star, highlight, write down the words power fight for yourself, because we're just comparing the highest powers. Okay, now algebraically, look how nice this is. Excuse me. In the numerator, you have x to the 5th, and in the denominator, you have x to the 5th, and anybody divided by itself just cancels out. So the answer to this limit, in fact, is 4/6 or 2/3. It just reduces so nicely. I did graph this out. So let me just zoom in on my graph. I did try to graph this. Whoops, I'm not going to be able to zoom in for some reason. There we go. I did graph this function just to compare to you, that is, or explain to you, that as x goes out to infinity, and this is a height of 1, you can see my tick mark of 5 there, that this function, as x goes out to infinity, is approaching a height of 2/3, which is the answer that we just got algebraically. So you'll come to find out, although it's called calculus, we don't really use our calculator very often. Your exam is, I guess I would say it's 50-50, but for the most part, it's not for anything that you would need it for yet. It's for true calculus calculations. So try not to get used to thinking you can just graph things, I guess. All right, let's take a look at another one. So again, pause it, write it down, turn it back on. All right, so we've got the limit as x approaches infinity of this function. So again, when I see infinity, I'm thinking this is so stinking gigantic that all these other terms don't matter. I just want the biggest powers. I want to see a power fight. So I'm going to rewrite this limit as x approaches infinity, and I just want the largest power in the numerator. So this means nothing. So I have 3x cubed. And in the denominator, now what they like to do is switch up the order on you, so don't just take for granted the biggest is always first. X cubed here. And again, this one turns out really nice. You'll notice that the x cubed over x cubed cancel, so this limit is actually 3. And again, it's because it divides out very nicely. Now, is that going to happen every time? No, but it's great when it does. All right, try another one here. Number 5. Let h of x equal this function. Find the limit as x approaches infinity of h of x. All right, so again, infinity, I'm thinking huge, so I'm going back to my head, power fight. As x approaches infinity, I want to be thinking power fight. All right, so I'm going to rewrite my limit as x approaches infinity. And again, infinity squared times -3 is much smaller in this case than 7. The 7 has no effect on it. I'm going to take the largest power on top, and the largest power on the bottom, which just happens to be x. And I'm going to clean it up like I said. Now, notice this one isn't as nice because everything doesn't cancel, but it does simplify. So I have the limit as x approaches infinity. X squared divided by x is just x, so I have negative 3x. All right, now we have to think through this a little bit. What are we doing? Well, we're going back to direct substitution, basically. If I take infinity and substitute it in here, and I ask you, what is negative 3 times infinity? Well, it's a really, 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 really tiny number that you can't count to. And notice I'm saying tiny, because obviously if you think of a sign chart, the big numbers are this way, the small numbers are this way. I'm going negative infinity way down here. I'm going to say negative 3 times infinity is just equivalent to negative infinity. And again, that 3 is just saying it's even bigger than, or smaller in this case, than infinity. All right. Try another one. Number 6. All right, so infinity, the limit as x approaches infinity. So power fight in your head. The limit as x approaches infinity. So I need the biggest power on top, biggest power on the bottom. Rewrite it for yourself. So again, I'm going to say that 4x squared over x cubed. I'm going to clean it up for myself. So this cancels. So I really have the limit as x approaches infinity of 4 over x. Okay. And now I'm just going to talk myself through that direct substitution again. I have 4 divided by infinity, 4 divided by a giant, giant number. And if you know that answer off the top of your head, that's great. And I'll kind of just talk through fractions if fractions haven't been your thing, but we do deal with a lot of fractions. And I think the easiest way to think about it is think about a piece of pizza or an entire pizza. If I cut it in half and I say, okay, I'm going to give you, everyone's going to get equal portions. We'd each get a half, right? And that's pretty obvious to see how much you're getting. Okay, so that's 1/2. You can think about how big that pizza is. Now, if I take that same pizza and I cut it into quarters, did you get a bigger piece or a smaller piece? If I'm only going to give you a 1/4 now, your piece of the pie is much smaller. And notice the denominator did what compared to the 1/2? It got bigger. Okay, so let me take that piece of that pizza, and I'm going to cut it into eighths. So now you're only going to get 1/8 of that piece of pizza, or that slice. The pizza. Did your slice get larger or smaller? Okay, so clearly, as the denominator gets bigger, the function itself, the amount of pizza you're getting, is actually getting smaller. If I tried to divide this, and obviously this is not going to look pretty, there's 8, 10, 12, 14, 16. That's only 16. You have to divide this by infinity. You have to divide it by a gigantic number. And if I keep cutting this up, your slice is so tiny, tiny, tiny that it's almost nothing. So when you take 4 and you divide by a huge number, you end up getting approximately the limit is intending to reach 0. Okay? Obviously, you might get a tiny little crumb, but the intentions are if you keep cutting that crumb up, you'll have nothing eventually. You're going to eventually get to 0. So when we take any number divided by a bigger number here, an infinite number, we're going to get 0. Number 7. So I've got, and obviously the question that we're tackling here is the limit as x approaches infinity. And here's my function f of x. So I'm just going to clean it up. I'm looking for the largest power on top. I've got negative 6x squared. Largest power on the bottom, x squared. Beautiful, simple one. Those are going to divide out. Therefore, my limit is equivalent to negative 6. All right, so now they get a little more interesting with the radicals involved. So we're going to tackle this question and the limit as x approaches negative infinity as well, because these are very, very common questions. So the limit as x approaches infinity of this function. So again, we want to clean it up because infinity is so large, one of these terms is going to dominate over the other. So again, I just want to hint at what I'm saying here. 4 times infinity plus 1, 4 times infinity is going to dominate whatever I, plus that plus 1 part. So my largest power on the bottom here, I'm going to say is 4x. So I'm going to rewrite this as the limit as x approaches infinity. And I've got my just 4x because this is going to dominate that function. You can ignore that. And now when I look at the numerator, I still have the square root. I can't get rid of the root, but I'm still looking for the largest power. So I'm going to get rid of this piece and just say this 4x squared is going to dominate. Now, this should clean up nice in this problem. So I really have the limit as x approaches infinity. Because there's no plus or minus, I can take the square root of both of these terms. So this just becomes 2x. And it actually, let me hold my thought here, it becomes the absolute value of 2x. Okay? When you take the square root, don't forget you get the plus and minus. So I'm going to get the absolute value of 2x all over 4x. Now, based off the ratio of the coefficients, I have this x over x. I'm going to say I get a 2/4 or 1/2. Okay, so I think this is worth, again, starring, highlighting. When you take that square root, we have to make sure we take the absolute value of it. And if you're wondering why, I just want to be clear. 2 times 2 is 4, and -2 times -2 is 4. So that's why we're saying the absolute value. Now, let's go ahead and add on to this question the limit as x approaches negative infinity. And obviously, it's the same power fight here. So I'm going to have the square root of 4x squared all over 4x. And we're going to say that reduces to the absolute value of 2x over 4x. All right, so now I want you to think about this. When you substitute negative infinity in, let's just talk about the sign, whether it's going to be positive or negative, because we know these x's are intending to cancel. So the number should still be a 2/4. Now we just have to determine whether it's positive or negative. 2 times negative infinity is negative infinity. But when I take the absolute value, that's going to get me a positive infinity. And then 4 times negative infinity is going to get me a negative infinity. So I'm going to say the answer this time is going to be a -1/2. Okay, so again, I knew the answer was still 1/2 or 2/4 because these x's are the same. Therefore, it's just this ratio of these coefficients. But I did need to test whether I'm getting a positive or negative number. And if I went too fast for you, feel free to pause it, rewind it, but you're going to see some more practice here in a minute. All right, so this question asks specifically about negative infinity, but we'll practice both negative and positive. So again, let's clean the function up because it is an infinite limit. We're going to think of our power fight. So the numerator would just be 3x. That's the largest power. Largest power on the bottom is going to be, keep that square root of 16x squared. Okay, so I have the limit as x approaches negative infinity. This is 3x. When I take the square root, remember we just started or highlighted, we need the absolute value. So this becomes the absolute value of 4x. Okay, so I have 3x over the absolute value of 4x. So let's just talk our way through it. If I substitute in negative infinity, 3 times negative infinity is going to be a negative huge number. And 4 times negative infinity is a negative number, but the absolute value is then going to make it a positive number. So the sign of this answer, a negative divided by a positive, should give me a negative value. Since these are both x's and they can divide, I'm going to say this final answer should be -3/4. Let's try the limit as x approaches positive infinity. So we already know it's the same thing here, and we're going to get the 3x over the absolute value of 4x. If I substitute infinity in, 3 times infinity is a positive, 4 times infinity is a positive, and the absolute value is still positive, so I know this answer should be positive. And then again, those ratios of the coefficient, those x's divide out, so I'm going to say the answer should be a positive 3/4. All right, take a minute and try number 10 for yourself. Pause it, and I'll kind of write my information out as well, and we'll talk through it. All right, I think I've got mine written out here. So I reduced I rewrote it with my largest power on the top and bottom. So then I said the square root becomes the absolute value of 2x. Square root of 4 is 2. The square root of x squared is x. Then I went and I checked my signs. So if I take negative infinity and plug it in top, I get a negative, but the absolute value makes it positive. And 4 times negative infinity is negative, which tells me my answer should be negative. And then again, because these coefficients are x and x, they divide out. I should be a negative 2/4 or a negative 1/2. If I were to take the limit as x approaches positive infinity of the absolute value of 2x over 4x, in the numerator, 2 times infinity and its absolute value would be positive. 4 times infinity is positive. So I would say this one would be a positive 1/2. So you notice the only thing that's changing is that sign, whether it's positive or negative. And just because this is negative doesn't always mean the answer is negative. It really depends upon what the function is. All right, we'll try one more of these. So I've got the limit as x approaches negative infinity. Again, a good idea, pause it, try it on your own, and we'll compare. So hopefully you can follow through my work here. I took my largest power on the top and bottom. I said the 4x to the 6th, the square root of that became 2x to the 3rd, and of course the absolute value of that. When I substituted negative infinity in, a negative number cubed is negative. A negative number here cubed is negative, but the absolute value makes it positive, so I know my solution should be negative. And then again, they were same variable, so I just said negative 5/2. All right, we're going to quickly scan something. And again, you might hear me referring to it as that power fight. And there's kind of a quick method you can look for. If you see the same over same, so what do I mean by that? Something like 5x cubed over 6x cubed. Okay, because those divide out, we like to say the answer is the ratio of the coefficients. Okay, so if I were to take the limit of this, my answer would be 5/6. It's just the ratio of the coefficients. If I see a small over large, something like x cubed over x to the 5th, okay, small meaning the smaller exponent in this case, and this one's larger, a larger function, small function over a large function. We said if we take any number and we divide by a larger number, because remember we're plugging in infinity, we are approximately getting 0. Okay, and if we take a large over a small something, let me just flip that, x to the 5th over x squared. Okay, that reduces to something like x cubed. And if I plug infinity in, infinity cubed is still going to be infinity. So you're going to get either, I'm just going to put a plus or minus, depending what the function is, a positive or negative infinity. So you're basically looking for 3 things. Ratio of the coefficients, if the same exponents there, or same functions. Small over large will always be 0, and large over small will always be plus or minus infinity. In this last example here, let's talk about who is actually larger in that numerator. Is 2x larger or is sine of x larger? So again, picture 2 times infinity, pretty large. Now let's picture sine. 0, max, 0, min, 0. No matter how far out I go to infinity, as x goes out to infinity, the sine of x is always bobbling between what 2 numbers? -1 and 1. It only ever gets to a height of 1 and as low as -1. So this here is some number between -1 and 1. So when we're talking about our power fight, we're talking about who's going to dominate in the numerator. I believe it's going to be 2x, not sine of x, because sine of x is actually, as x goes out to infinity, again, is pretty small. It's just between -1 and 1. So I'm going to compare 2x over x, which of course, these are going to divide. So the ratio of the coefficients just gives me a number of 2. So hopefully we learned something new today, and we'll have a little bit of practice to go with it.